Okay, this is a logic design lecture for Friday, February 4th. And we didn't start at the beginning, but we're just working some examples of converting from POS to SOP and SOP to POS using switching algebra. All right, so when I use the first distributive law, how am I applying it to the problem we just did? How did I apply it to the problem I just did? Would you draw the arrow in this direction, or would you draw the arrow in that direction? Top
I'm
arrow
sorry,
or
could
bottom?
you share your
Oh,
where
you
you're
don't-
writing?
Yeah, you don't see the screen again, sorry. Yes. So here's the first distributive law, right? Which way am I applying it?
Wouldn't it be from left to right? Because
That's
the
right.
one on the left is a sum of products, and while the one on the right is a product of sums.
That is exactly right, and that's how you should think about it. Yes. So whenever you apply those theorems, be careful to apply them in the right direction. It's easy to get confused and to not apply them in the right direction. So make sure you do that. That's right. So whenever you do it, you write out the theorem. We also used the second distributive law. So that was x plus yz equals x plus y quantity times x plus z quantity. Which way do we apply this? Left to right or right to left? Anybody?
Again, left to right.
That's right. We applied it this direction because this is SOP form and this is POS form. And even when we're sort of in an intermediate form, moving from this to this, we still have to apply it this direction to make it work. If we flip it around, we will go back to where we started. And that's the reason for it's really helpful to write this theorem out and put an arrow on it showing how you're going to apply it. And the same with multiplying and factoring, C3. So how do we apply that? So xz plus x prime y equals, we take the x with the y and the x prime with the z. So that's x plus y quantity times x prime plus z. So we apply that also in this direction. And of course, it can be applied in either direction. So you have to be careful. The little brackets will help keep you straight on that one. You don't have to do them, but I think that's a good idea. All right. So when you use the theorems, try and apply them in the right direction. And write them out, put the arrow on top, and then apply the theorem. And then eventually you can take the training wheels off, and you don't have to necessarily do that. But if you don't do that initially, I guarantee you'll go in circles on some problems. All right, let's do another one. So here we have these are 5 different problems. So let's work a couple of these. So this one we want to multiply out to obtain a sum of products. So k prime plus m prime plus n, k prime plus m, L plus m prime plus n prime, k prime plus L plus m, and m plus n. All right. And we want to, and it tells us 3 terms. So we want to get three POS terms, 3 SOP terms when we get it converted. So if you look at this form, it is in POS form now, right? And we want to go to SOP. We call that multiplying out. So the first thing to do is to inspect it to see if there's any hope that we can eliminate some terms. So as you look at this, do you see any? So we might want to apply. Put this in here. So we might want to apply one of our theorems. So let's think through the first. So S1, S2, and S3. Let's think about these. So one theorem, X, Y, or actually we want to go the other direction. So X plus Y quantity times X plus Y prime equals X. Now, do you see anywhere we can apply that? And that's of course S1, and we're going to apply it in this direction. or S2, let's see, we can even go back and look at S2, where we have a literal. That's probably not, we maybe can't apply that one here, but yeah, so that would be x plus x prime y equals x plus y, where we might, actually we should do x plus, or x times quantity. Yeah, let me pull up the rule so we don't. So eliminate the literal. So it's x times x prime plus y equals x, y. And actually, that's easy to see because you can multiply it out, put the x in here, and you get x prime, which is always x AND with its inverse is 0. So then you just write it with x, y. But anyway, that's the POS form. And then eliminate a term. So xy plus x equals x, and x plus y times x equals x. Okay, so
Dr. Morton, we can't see what you're writing.
yeah, right. I'm gonna flip it back. You're looking at it. I'm just copying these. All right, let me bring this back. So there are theorems. What do you see that we might be able to use on this problem? Can you simplify it? Can you apply any of these simplification theorems? S1. So this is the SOP form. So S1, S2, or S3. So does anybody see any? Well, do you see any examples where you can apply S1? Or do you see any examples where you can apply S3? All right, let me give you some hints. So we have a K prime plus an M here. So let that equal X. And so that would be the X. And then do you see where we have a K prime plus M plus something else? Well, here's
Yes,
a K
sir.
prime. Okay, go ahead.
It'd be, yeah, that 1, 2, 3, the fourth term, K prime plus L plus M.
That's right. So you can basically just drop that term out. Since you have K prime plus M quantity times, if we rearrange it, K prime plus M plus L. Then if this is X and this is X plus Y, then that clearly can just be X. So this term goes. Does everybody see that? So now we can rewrite it. K prime plus M prime plus N times K prime plus M, our term here, plus this term, L plus M prime plus N prime. Then we drop that term, and then we just have M plus N, M plus N. All right, now, don't really see, yeah, I don't really see any other applications we can make, but now we're down to 4 terms. So we've saved ourselves a little grief. All right, now what do you want to do? So maybe we'll expand this. All right, so there's where we're starting. All right, any ideas for how you might want to attack this? So is there, first off, is there a term that appears in every single, is there a variable that appears in every single term?
Would that be M, sir?
Yeah, so M does appear in every single term. So that might be a good one to focus on. So let's organize them where we have the M's. So let's rewrite them and we'll put the M first. So we have M plus K prime. And we have M plus N. And then we have M prime plus K prime plus N. And we have M prime plus N plus L plus N prime. So all right, so now, so we can do a couple of different things. Obviously, we could use the second distributive law here because we have M's. So let me write that out. So that's X plus YZ equals X plus Y quantity times X plus Z. So which way are we applying this law? Are we applying it right to left or left to right?
Right to left.
Right to left is correct. So I'll draw the arrow. So now we're looking for an X plus Y, so M plus K prime, so Y is K prime, and an X plus Z, so N would be Z. And we wind up with M plus K prime N. And so now this is this times this over here. Same thing here. That can be an X, this can be our Y, that can be our X, and this can be a Z. So now we can do the same thing here. We wind up with X plus Y times Z, are the quantity, K prime plus N times M prime plus L plus N prime. All right, now what do you want to do? Well, we probably need to do something with this, right? So what do you see that what might we be able to do with this situation here? Well, so it looks like we have an N and an N prime. So we could use the second distributive law with this in here. I'm sorry, the multiplying and factoring. So C3, the third conversion rule. And so we have an N and an N prime. So we can take the N with this, and the N prime we can take with this. And that's going to give us N. And let's see. So it's going to give us N times this. So this whole thing here, N times M prime plus L, and plus N prime times K prime. And so we've got all this here now, and still X plus that times M plus K prime N. All right, so yeah, so what do we do with this? Well, so then we can distribute the N in here, but we still need a little help here. All right, so. So some way we need to, we're gonna have to get this worked out with this. So how can we do that?
Professor, should we not factor out that M prime in the second line from the bottom? Would be like M prime plus K prime plus N times L plus N prime.
Yeah, I'm not sure what you're asking. I mean, here, multiply the N in.
No, so the line above that. where
Okay,
we-
here. What do you want to do?
So wouldn't the X be M prime in that equation? And then it'd be M prime plus K prime plus N multiplied by just the L plus N prime.
Okay, so you're saying, say that one more time. I didn't follow you.
So would it not be N prime plus the K prime plus N times just the L plus N prime? Because wouldn't that N prime be factored out from the line above?
No, so what you get is you get N prime, K prime. So this N prime goes with the K prime. So it's N prime, K prime plus N times this quantity here. N prime plus L,
Okay,
like that. And so then, then we can do N, M plus N L plus N prime, K prime. So that's all fine. And so we have X plus that. Yeah, I may have gone down a bad path here. And then we have M plus K prime N. So we took this. So these two give us this, and these two give us this, but they're still multiplied times each other. So we didn't, so at this point, now we sort of have to figure out kind of what to do next. And yeah, I don't know. I may have to look at this one. Some of these are actually, like I said, some of them are really tricky. And even at this point, some are tricky for me. If I go down the wrong path, sometimes I wind up with it's difficult to figure out what to do next. The good news is that there are other means of solving them. So then you can always do that, like you can do a K-map and then see where you went wrong. Yeah, maybe I obviously have worked this before, but I don't actually remember off the top of my head. So rather than spend any more time on it, I'll work on it. I'll go through it Monday then for you. Let's do the next one. Some of these have to be a little easier. Some of these are actually fairly tricky. So we'll leave that one for now. Let's just do B. So here we have K prime plus L prime plus M prime, K plus M plus N prime, K plus L, K prime plus N, K prime plus M plus N. So if you look at this, and there's probably a consensus term, that's probably where we're messing up here. And that would have helped us, even though I talked about, yeah, but that's right. Okay, well, anyway, so let's do this one. So what do you see that we can do here? Are there any terms that we can eliminate? So we have a K prime plus N. So I see a K prime plus M plus N. So we can drop this term. And then we have a K plus L. Does that help us in any way? Well, no, it doesn't look like it does. So it looks like we wind up with 4 terms again. So let me copy that down and we'll do this. I don't think I had, I'm not sure if I don't think I had. Yeah, I didn't put the answers in for those. I will do. All right, so let's pop this back up. It's kind of unsatisfying to leave that one unfinished, but that's what we're going to have to do for now. All right, so let's do this one. All right, so I'll just copy it down here. K prime plus L prime plus M prime. and then K plus M plus N prime. And K plus L. And K prime plus N. And K prime plus M plus N. Now, this is M. All right. Now we'll expand this. All right, so now we look at this, K prime plus L prime plus M prime. And we had a K plus L, so we have a K and a K prime plus N and a K prime plus M plus N. So this term we can eliminate using our simplification 3 theorem, okay? Because we have a K prime N and a K prime N plus M here. So that's the same as quantity at X times the quantity X plus Y. All right, so we got rid of that term. And then K plus L doesn't really help us anywhere else. This doesn't help us, K prime plus N. And yeah, so we don't really have anything else we can do. All right, so we have now these 4 terms, 1, 2, 3, 4. Okay, so we do have a K in every term, so we can use that feature, and we can organize them K prime plus L prime plus M prime quantity times K prime plus N times K plus M plus N prime times K plus L. All right, so that's one thing we can do. We can factor out the K prime. And yeah, that's what we should have done up there. Maybe I did. Okay, well, anyway, so we're going to use the second distributive law. Remember, so X plus Y, quantity times X plus Z equals X plus YZ. And we're going to apply it in that direction. So in this case, we have K prime as X. So it's K prime plus N times the quantity L prime plus M prime. And then all that times K plus L times M plus N prime. Now we can distribute the L in, so that gives us K prime plus N L prime plus N M prime times K plus LM plus LN prime. Now we have a K and a K prime and a X and a Z here. So we can use the multiplying and factoring, or C3, and we can take K with this, K prime with that, and K with this. And so that's just going to give us K prime times LM plus LN prime plus K times NL prime plus NM prime. All right, and now we can just distribute the K's in, and we get K prime LM plus K prime LN prime plus K NL prime plus K NM prime. And that's what I should have done with the other one. I should have used the multiplying and factoring, and that would have put me in a much better situation. So now we have 1, 2, 3, 4 terms, and it's in SOP form. All right, and I don't think any of these, yeah, this all looks fine. All right, so that's that one. Let's maybe I'll go back and do this other one now. Yeah, let's go back and look at this other one, and maybe we'll try and I'll try and take a slightly different path and not get into as much trouble. So again, we eliminated the one term. We eliminated the K prime plus L plus M term. All right. So we have K prime plus M prime plus N quantity times K prime plus M. And then we have L plus M prime plus N prime. M prime plus N prime. And then we eliminated this term, the K prime plus L plus M, because of K prime plus M. So then we just have M plus N. Now we look at this. And so do we have any terms that appear in all of them? Yeah, and M appears in all of them. So now we probably want to rearrange them. So we have the M primes together and the M's together. So we'll do M prime plus K prime plus N. And then we'll take this one, M prime plus L plus N prime. And then we'll take the M plus K prime, and M plus N. All right, now we can use the multiplying and factoring. Well, first we should do second distributive law, which is X plus Y quantity X plus Z equals X plus YZ. And we're going to apply it first to this group using X as M prime, and then we'll apply it to this group using X as M. So when we do X as M prime, then that should give us M prime plus the quantity K prime plus N times N prime plus L. So we have an N prime and an L here, so we can use the M and F inside here. And that'll give us N prime K prime plus N L. And so it's plus M prime plus this. And then here, we don't really have to do anything to this, well, except apply the second distributive law, and that'll give us M plus K prime N. Yeah, and now we have an M and an M prime, and so now we can take the M prime with this and the M with this, and that gives us M times K prime N plus M times this quantity, N prime K prime plus N L.
We
And
can't see.
sorry. So we get M prime times this, M prime times K prime N. So that's just M prime K prime N plus M times this quantity, N prime K prime plus NL. And so we can distribute the M in M, N prime K prime plus M, N, L. So now we have 1, 2, 3 POS SOP terms. And that's what the problem specified. All right, so going that way, we get to a solution fairly reasonably. Going the other way, it was kind of difficult, and we kind of hit a blind end. And that's a good illustration of why, try it one way, doesn't work, try it another way. Because some of them, some approaches can kind of lead you down a blind alley. And I'm not exactly sure what I did wrong, but anyway, but just not applying the rule, applying the theorems in the right order can leave you in in a situation where you can't really you can't do the conversion. And you know that in every case, the conversion is possible. You can always convert from SOP to POS. You can always convert the POS to SOP. There's no situation where you can't. It's just that sometimes you get stuck when you don't apply the theorems in the right order. And that's true for me, and it's true for you. So, all right. Let's see how we doing on time. So let me do one more quickly. So if we move this down, so let's look at this one. They kind of all look the same, don't they? All right, K prime plus L prime plus M, K plus N prime, K prime plus L plus N prime, and K plus L, and K plus M plus N prime. All right, so K plus L, let's see if we have a K plus L. Nope. Do we have a K plus N prime? K plus M plus N prime? Yes, we do. So this term can go. So that leaves us the first 1, 2, 3, 4 terms. All right. So we can approach that similar to what we did before. So we just have the first 4 terms, and I'll organize them with the K prime. Since we have a K in every term, I'll organize them with the Ks. So we have a K prime plus L prime plus M. And then we have a K prime plus L plus N prime. And then we have a K plus L and a K plus N prime. So K plus N prime and K plus L. So we have our 4 terms. The 5th term we eliminated using C3, S3, where we simplify it by x plus y times the quantity x plus y times the quantity x plus y plus z. So, or times x if you want. That's how the theorem. So the theorem was actually written x times x plus y equals x. But you could also write it x plus y times x plus y plus z equals x plus y. So this is really what it looked like, and we applied it in that direction. Same with this. All right. So now we have these 4 terms organized with the K prime in each term, K or a K prime in each term. So so the first thing to do is just do exactly the way we did the other one. Apply the second distributive law with K prime being X for these 2 terms, and apply it again with X being K for these 2 terms. So if we do that, we get K prime plus the quantity L prime plus M times L plus N prime. And over here, all times, over here we have K plus N prime L. I guess we didn't need a second thing. All right. And then let me go ahead and expand this. So now we can work on what's in here. What law would you suggest we apply here?
Because we have an L prime and an L, we can distribute out, right? Or
Multiply and factor. Yeah,
yeah, multiply and factor, sorry.
exactly right. Yep, that's what you want to do. So we do this little puppy over to here, and this one over to there. So that's going to give us L prime N plus L M. There weren't any primes there, right? Yeah. So L prime N plus L M. Quantity, well, K prime plus that. So actually don't need the brackets there either. And then we have this times this over here, K plus N prime L. Now what do you think we might do? How about we use the multiplying and factoring on the whole thing with the K and a K prime. So this K goes over and takes that, and this one does this. Now, so this is going to be K prime times this plus K times this. So it's going to be K prime times N prime L plus K times this quantity, L prime N plus L M. Well, K prime, we just take the brackets away, K prime N prime L plus K L prime N plus K L M. We have 1, 2, 3 terms for this one, and it is in SOP form. All right, so let me stop. So those are some examples of some problems on the more difficult side. Let me just give you 2 things, examples that let me just do this real quick. I know we're, yeah, it's 11:03. So if anybody doesn't want to stay, I'll just include this in the video and you can go back and watch the end of the video. But I just want to cover 2 quick things that will come up frequently. So let's say you have a problem with, say, x plus y times x plus z times x plus w. Okay, so we remember the second distributive law, x plus yz, but there's also kind of this corollary, x plus yzw. And we know that this equals quantity x plus y times quantity x plus z. So we're going to apply it in this direction, but this corollary is just x plus y quantity times x plus z quantity times x plus w. And you apply that same direction. So in this case, we can just write the answer as x plus y, z, w. And now that's in SOP form, and this is in POS form. All right, so that's one that comes up frequently. And another one that comes up all the time is this xy plus wz, or something equivalent to that. And it turns out we just use the second distributive law a couple of times. We let this be x, this be yz, and we get xy plus w times xy plus z. And now we apply the second distributive law here, and we apply it again here, and we get w plus x quantity times w plus y quantity times z plus x quantity times z plus y. So these 2 examples come up frequently, and you should just practice those and make sure you can recognize, because those are typical things that you might see on a test. And those are a little easier to deal with. I probably won't give you something that's really tricky and which you can, which there are about 10 different ways to approach, because it's really hard to grade that. And I'm not, our goal here is not to make you necessarily experts at switching algebra. We want you to have a familiarity with it, and we want you to be able to do, fairly straightforward calculations. But I'm not really focused on you being able to, solve really difficult switching algebra problems and get the solutions, because we have automated tools for that. And so what I want you to really, more than anything, be able to do is to recognize when your automated tools are lying to you, because you have some familiarization with, how it ought to go. I think that's the real skill that you as an engineer needs with really everything. You don't have to do, you don't have to be a master at solving, integrating and differentiating and solving differential equations. What you really need to be able to do is to have a sense of what's going on in the tools that you're using, and whether they're like really broken and giving you horrible answers, or whether they seem to be working appropriately. And then to know ways of sort of verifying and checking it just to make sure. That's really the skill. That's the ability. Very rarely in your career, you're going to have to sit down and solve a differential equation. Maybe never. And if you did, you'd probably want to get some expert assistance in working through that either with a, you know, a mathematical based tool or with, you know, some mathematical expert to really look over your shoulder and just verify things. If you happen to be working on some one-off project where you're breaking really new ground. But most of the time, you're gonna be working through things that have fairly established solutions already built in, especially in the digital design world. All right, with that, we'll quit, and we'll see you then on Monday in class. I guess if the weather and COVID cooperate, but currently that's the plan. Make sure you look on ASAP, and I think you'll find this will be a lot easier to comprehend in class. It is a little, it's a little tougher online. All right, we will see you guys Monday in class.
Dr. Morton?
Yeah.
Quick question about the homework. I know you didn't set a due date, but do you have like a tentative due date for homework 1 and 2?
Yeah, so no, as far as I'm concerned, I want you to do those and be prepared to discuss them in recitation with the TA. And I'll get on him to schedule some more sessions, or maybe we'll even do it. Maybe we'll go over those. Why don't you do them by Monday, and we'll go over them in class on Monday, but I'm not going to have you turn them in as homeworks. We'll start with homework 4, and I will put a due date. I'll put the due dates. I'll change the syllabus and put the due dates with a turn-in link on Blackboard. And
Awesome.
I'll probably make the first one due on Friday next week.
Appreciate it.
And that'll be homework session 4. Okay. Any other questions? That's a good question. All right. I'll send out an email explaining that approach. All right. We'll talk to you later.